प्यारे विद्यार्थियों, अपनियां पहलियां क्लासां विच असी आयोनिक बॉन्डिंग एंड कोवैलेंट बॉन्डिंग बारे पढ़ चुके हाँ. Both of these are ultimately driven by the fact that atoms require complete shell of electrons for maximum stability. They achieve this by either gaining, losing, or sharing one or more electrons. There are other forces of interactions which play important role in understanding the chemistry of different systems. They are metallic bonding, dative bonding, dipole-dipole interactions, hydrogen bonding. ਅੱਜ ਦੇ ਇਸ ਪਾਠ ਵਿੱਚ ਅਸੀਂ ਹਾਈਡਰੋਜਨ ਬੌਂਡਿੰਗ ਬਾਰੇ ਪੜਾਂਗੇ. Hydrogen bonding. Children, today we will learn about hydrogen bonding and its types. When hydrogen atom is bonded to atoms of highly electronegative elements such as fluorine, oxygen, or nitrogen, the hydrogen atom forms a weak bond with the electronegative atom of other molecule. This weak bond is called hydrogen bond. For example, in hydrogen fluoride, represented as HF, hydrogen atom forms a weak bond with fluorine atom of the neighboring molecule while remaining bonded to its fluorine atom. This may be shown as the bonding shown on the screen. We can also say that hydrogen atom acts as a bridge between two atoms, holding one atom by a covalent bond and the other atom by a hydrogen bond. The hydrogen bond is represented by dotted line and the covalent bond is represented by solid line as shown on the screen. As a result of hydrogen bonding, hydrogen fluoride exists as a chain of hydrogen fluoride molecules and is represented as shown on the screen as HF whole N. Thus, the attractive force which binds hydrogen atom of one molecule with electronegative atom of another molecule is known as hydrogen bond. Children, let us now talk about strength of hydrogen bond. What do you think about its strength? Will it be weaker or stronger than a covalent bond? Let me tell you. Hydrogen bond is much weaker than a covalent bond. The strength of hydrogen bond ranges from 10 to 40 kilojoules per mole, while that of a normal covalent bond is of the order of 400 kilojoules per mole. So, a hydrogen bond is about 1/10 of the strength of a covalent bond. Thus, the bond length of a hydrogen bond is longer than that of a covalent bond. Let us take an example to explain this. In case of hydrogen fluoride molecule, the covalent bond between hydrogen and fluoride is 109 picometers, while the bond length of hydrogen bond between fluorine and hydrogen is 155 picometers.
Children, can you think of any of the causes of hydrogen bond formation? Cause of formation of hydrogen bond. When hydrogen is bonded to strongly electronegative element X, as you are seeing on the screen, the electron pair shared between the two atoms is pulled far away from the hydrogen atom, which results in the formation of a dipole. As a result, hydrogen atom becomes highly electropositive with respect to the other atom, since the electrons are displaced towards X. It acquires partial negative charge represented by delta negative, while hydrogen atom gets partial positive charge represented by delta positive. In other words, the bond HX becomes polar and may be represented as shown on the screen. The electrostatic force of attraction between positively charged hydrogen atom of one molecule and negatively charged atom of neighboring molecule results in the formation of hydrogen bond. This may be represented as depicted on the screen. Points to be noted are: only oxygen, nitrogen and fluorine, which have very high electronegativity and small atomic size, are capable of forming hydrogen bonds. Hydrogen bond is longer and much weaker than a normal covalent bond. Hydrogen bond energy is less than 40 kilojoules per mole, while that of covalent bond is about 400 kilojoule per mole. Hydrogen bonding results in long chains or clusters of a large number of associated molecules. This implies that the atoms X, H, X will be in a straight line.
Children, now that we have learnt so far, what do you think can be the necessary conditions for hydrogen bonding? Let us discuss them one by one. Let us take up the first one, that is high electronegativity of atom bonded to hydrogen. The molecule must contain an atom of high electronegativity such as fluorine, oxygen or nitrogen bonded to hydrogen atom by a covalent bond. The common examples are hydrogen fluoride, that is HF, water, that is H2O, and ammonia, that is NH3. Let us now take up the second point that refers to the small size of electronegative atom. The size of the electronegative atom should be quite small. This is due to the fact that the smaller the size of electronegative atom, the greater will be its attraction for the bonded electron pair. This will cause greater polarity in the bond between hydrogen and electronegative atom, which results in stronger hydrogen bond. For example, ammonia shows hydrogen bonding while hydrogen chloride does not, although both nitrogen and chlorine have the same electronegativity of 3. Hydrogen bonds are not formed by chlorine because of its bigger size than nitrogen.
Let us now discuss the differences between hydrogen bond and covalent bond. As you see on the screen, hydrogen bond involves dipole-dipole attractions, while covalent bond involves sharing of electrons. Hydrogen bond is formed between hydrogen atom and a highly electronegative atom such as fluorine, oxygen or nitrogen. while covalent bond is formed between any two electronegative atoms which may be of the same element or of different elements. Strength of the hydrogen bond is very small. Strength of hydrogen fluoride bond is 41.83 kilojoules per mole. Bond strength of covalent bond is sufficiently high. For example, of HH bond is 433 kilojoules per mole.
That was just great to know about differences between hydrogen bond and covalent bond. Now, before moving ahead, let us try to look at few examples of hydrogen bonded compounds. Let us discuss a few examples of compounds which exhibit hydrogen bonding.
Hydrogen bonding in a hydrogen fluoride molecule. Hydrogen fluoride. When hydrogen is bonded directly to a small sized, highly electronegative atom such as fluorine, oxygen, or nitrogen, the resulting bond is very polar with the positive charge located on the hydrogen atom. This charge is attracted by the corresponding negative charge on electronegative atom in another molecule, resulting in strong dipole-dipole interactions called hydrogen bonds. In the solid state, hydrogen fluoride consists of long zigzag chains of molecules associated together through hydrogen bonds. Thus, hydrogen fluoride molecule is represented as HF whole N. In the liquid or gaseous state, the chain, however, becomes linear. Water. Let us now have a look at hydrogen bonding in water. In addition to two covalent bonds in water, oxygen atom forms two hydrogen bonds. As a result of two hydrogen bonds, each oxygen is tetrahedrally surrounded by four hydrogen atoms, two by covalent bonds and two by hydrogen atoms. The associated water molecules may be expressed as H2O whole N. Ammonia molecule. Ammonia molecule has an electronegative nitrogen atom bonded to three hydrogen atoms. Due to difference in electronegativity between nitrogen and hydrogen, each hydrogen atom acquires positive charge. Thus, in the molecule, there is one negative side and three positive sides, so that the molecules of ammonia associate through hydrogen bonding to form long chains. Children, let us now have a look at the types of hydrogen bonds. Hydrogen bonds can be classified into two types: intermolecular hydrogen bond and intramolecular hydrogen bond. Let us first talk about the intermolecular hydrogen bond. Intermolecular hydrogen bond is formed between two different molecules of the same or different substances. For example, hydrogen bond between the molecules of acetic acid. The crystal structure of acetic acid shows that the molecules pair up into dimers connected by hydrogen bonds. The dimers can also be detected in the vapor at 120 degrees Celsius. They also occur in the liquid phase in dilute solutions in non-hydrogen bonding solvents. In a certain extent in pure acetic acid, but are disrupted by hydrogen bonding solvents. The dissociation enthalpy of the dimer is estimated at 65 to 66 kilojoules per mole, and the dissociation entropy of 154 to 157 joules per mole per Kelvin. Similar intermolecular H bonding can also exist in hydrogen fluoride, ammonia, water, etc. Let us now take an example in which hydrogen bonding is involved in between the molecules of two different substances. Hydrogen bond in alcohol or water molecules. Intermolecular hydrogen bond results into association of molecules. Hence, it usually increases the melting point, boiling point, viscosity, surface tension, and solubility, etc. Let us now discuss intramolecular hydrogen bond. Intramolecular hydrogen bond is formed between the hydrogen atom and the highly electronegative atom fluorine, oxygen, or nitrogen present in the same molecule. Intramolecular hydrogen bond results in the cyclization of the molecules and prevents their association. Molecules exist as discrete units and not in associated form. Consequently, the effect of intramolecular hydrogen bond on the physical properties like melting point, boiling point, viscosity, surface tension, solubility is negligible. For example, intramolecular hydrogen bonds are present in molecules such as orthonitrophenol, 2-nitrobenzoic acid as shown on the screen.
Let us now discuss influence of hydrogen bonding on the properties. Hydrogen bonding has important effect on many physical properties such as melting point, boiling point, and solubility of the compounds. Let us now discuss the characteristics of compounds having hydrogen bonds. The first property is that of association. Due to intermolecular hydrogen bonding, two or more molecules of a compound exist as associated molecules. For example, carboxylic acids, that is RCOOH, exist as dimers even in the vapor state as shown on the screen. This results in the increase in the size as well as in the molecular mass of the compound. Let us now discuss the second one, that is abnormally high melting and boiling points. The compounds containing hydrogen bonds have high melting and boiling points. It is due to the fact that because of hydrogen bonding, the electrostatic force of attraction in the molecules become large. Consequently, larger energy is required to separate these molecules before they can melt or boil. The influence of hydrogen bonding on melting and boiling points can be understood by comparing the melting and boiling points of the hydrides of elements of groups 14, 15, 16 and 17 as shown in the chart.
Hydrogen bonding in hydrides. ਜਦੋਂ ਅਸੀਂ ਗਰੁੱਪ 14 ਐਲੀਮੈਂਟਸ ਦੇ ਹਾਈਡਰਾਈਡ ਦੇ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟਸ ਨੂੰ ਕੰਪੇਅਰ ਕਰਦੇ ਹਾਂ ਤਾਂ ਅਸੀਂ ਵੇਖਦੇ ਹਾਂ ਕਿ ਉਹਨਾਂ ਦੇ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟਸ ਮੋਲੀਕਿਊਲਰ ਮਾਸ ਦੇ ਨਾਲ ਗ੍ਰੈਜੂਅਲੀ ਇਨਕਰੀਜ਼ ਕਰਦੇ ਹਨ। All four hydride have symmetrical tetrahedral structure, ਇਸ ਲਈ ਇਨ੍ਹਾਂ ਵਿੱਚ ਕੇਵਲ dispersion force ਹੀ ਆਪਰੇਟ ਕਰਦੀਆਂ ਹਨ ਅਤੇ ਉਹ molecular mass ਔਰ surface area ਨਾਲ ਵੱਧਦੀਆਂ ਹਨ। ਗਰੁੱਪ 15 ਦੇ ਹਾਈਡਰਾਈਡਸ ਇੱਕ ਅਲੱਗ ਪੈਟਰਨ ਵਿਖਾਉਂਦੇ ਹਨ। ਫਾਸਫੋਰਸ, ਆਰਸੈਨਿਕ ਅਤੇ ਐਂਟੀਮਨੀ ਗਰੁੱਪ 14 ਹਾਈਡਰਾਈਡਸ ਦੀ ਟੈਂਡੈਂਸੀ ਨੂੰ ਫੋਲੋ ਕਰਦੇ ਹਨ, ਜਦੋਂ ਕਿ ਅਮੋਨੀਆ ਦਾ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਐਕਸੈਪਸ਼ਨਲੀ ਹਾਈ ਹੁੰਦਾ ਹੈ। ਇਸ ਐਨੋਮੈਲੀ ਨੂੰ ਅਸੀਂ ਹਾਈਡਰੋਜਨ ਬੌਂਡਿੰਗ ਦੀ ਸਹਾਇਤਾ ਨਾਲ ਦੱਸ ਸਕਦੇ ਹਾਂ। ਹਾਈਡਰੋਜਨ ਬੌਂਡ ਅਮੋਨੀਆ ਮੋਲੀਕਿਊਲਸ ਨੂੰ ਸਟਰੋਂਗਲੀ ਹੋਲਡ ਕਰਕੇ ਰੱਖਦਾ ਹੈ। ਇਨ੍ਹਾਂ ਬੌਂਡਸ ਨੂੰ ਤੋੜਨ ਲਈ ਐਕਸਟਰਾ એનર્ਜੀ ਦੀ ਜ਼ਰੂਰਤ ਹੁੰਦੀ ਹੈ, ਇਸ ਕਰਕੇ ਇਸ ਦਾ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਜ਼ਿਆਦਾ ਹੁੰਦਾ ਹੈ। ਅਜਿਹੇ ਹੀ ਐਨੋਮਲੀਜ਼ ਨੂੰ ਅਸੀਂ ਗਰੁੱਪ 16 ਐਂਡ 17 ਦੇ ਪਲਾਟ ਵਿੱਚ ਦੇਖ ਸਕਦੇ ਹਾਂ। ਵਾਟਰ ਅਤੇ ਹਾਈਡਰੋਜਨ ਫਲੋਰਾਈਡ ਦਾ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਐਕਸੈਪਸ਼ਨਲੀ ਹਾਈ ਹੁੰਦਾ ਹੈ। ਇਸ ਐਨੋਮਲੀ ਨੂੰ ਵੀ ਅਸੀਂ ਹਾਈਡਰੋਜਨ ਬੌਂਡਿੰਗ ਦੀ ਸਹਾਇਤਾ ਨਾਲ ਦੱਸਦੇ ਹਾਂ।
Let us now have a look at the influence on the physical state. Hydrogen bonding also influences the physical state of the substances in solid, liquid or gaseous state. For example, both oxygen and sulfur belong to same group, but H2O is a liquid at ordinary temperatures, while H2S is a gas. This is explained on the basis of electronegativity values. In water, oxygen is highly electronegative so that it forms hydrogen bonds. As a result, the molecules of H2O get associated with one another, and this raises the boiling point of water. Consequently, water exists as liquid at room temperature. On the other hand, the electronegativity difference of atoms in H2S is less, and hydrogen bonding in H2S is almost negligible. As a result, H2S is not associated and exists as a gas at room temperature. We will now have a look at the solubility. Hydrogen bonding also influences the solubility of one substance in another. For example, alcohol is highly soluble in water due to hydrogen bonding with water molecules as shown on the screen. Arrange the following in the decreasing order of their boiling points: hydrogen fluoride, hydrogen chloride and hydrogen bromide. And the answer is hydrogen fluoride has a higher boiling point than hydrogen bromide, which in turn has a higher boiling point than hydrogen chloride.
Biological importance of hydrogen bonding. ਵਿਦਿਆਰਥੀਓ, ਕੀ ਤੁਹਾਨੂੰ ਅਸਲ ਜ਼ਿੰਦਗੀ ਵਿੱਚ ਹਾਈਡਰੋਜਨ ਬੌਂਡਸ ਦੀ ਮਹੱਤਤਾ ਬਾਰੇ ਪਤਾ ਹੈ? ਚਲੋ ਅਸੀਂ ਇਸ ਨੂੰ ਡਿਸਕਸ ਕਰਦੇ ਹਾਂ। ਹਾਈਡਰੋਜਨ ਬੌਂਡਸ ਬਾਇਓਲੋਜੀ ਵਿੱਚ ਵੀ ਮਹੱਤਵਪੂਰਨ ਹੁੰਦੇ ਹਨ। ਇਹ ਲਾਰਜ ਪ੍ਰੋਟੀਨ ਮੋਲੀਕਿਊਲਸ ਨੂੰ ਸ਼ੇਪ ਦਿੰਦੇ ਹਨ। ਪ੍ਰੋਟੀਨਸ ਲੰਮੀ ਚੇਨ ਦੇ ਬਣੇ ਹੁੰਦੇ ਹਨ, ਜਿਸ ਵਿੱਚ ਕਾਰਬੋਨਿਲ ਗਰੁੱਪਸ ਅਤੇ ਅਮੀਨੋ ਗਰੁੱਪਸ ਬਰਾਬਰ ਦੂਰੀ ਤੇ ਹੁੰਦੇ ਹਨ। Hydrogen bonding occurs between a hydrogen atom bonded to the nitrogen in an amino group and the oxygen atom of carbonyl group. ਇਸ ਤਰ੍ਹਾਂ ਨਾਲ ਪ੍ਰੋਟੀਨ ਮੋਲੀਕਿਊਲਸ ਦਾ ਲੰਮਾ ਸਟ੍ਰੈਂਡ ਟਵਿਸਟਡ ਹੁੰਦਾ ਹੈ। ਜਿਸ ਨੂੰ ਕਿ ਅਸੀਂ ਐਲਫਾ ਹੈਲਿਕਸ ਕਹਿੰਦੇ ਹਾਂ। DNA ਦੇ ਮਹੱਤਵਪੂਰਨ ਡਬਲ ਸਟ੍ਰੈਂਡਡ ਹੈਲਿਕਸ ਵੀ ਹਾਈਡਰੋਜਨ ਬੌਂਡਿੰਗ ਦੇ ਬਿਨਾਂ ਐਗਜ਼ਿਸਟ ਨਹੀਂ ਕਰਦੇ। ਪਿਓਰੀਨ ਅਤੇ ਪਿਰਾਮਿਡੀਨ ਬੇਸਿਸ ਦੇ ਅਮੀਨੋ ਅਤੇ ਹਾਈਡਰੋਕਸਿਲ ਸਬਸਟੀਟੂਐਂਟਸ ਰਾਹੀਂ ਬਣੇ ਹਾਈਡਰੋਜਨ ਬੌਂਡ ਇਹਨਾਂ ਦੋਹਾਂ ਸਟ੍ਰੈਂਡਸ ਨੂੰ ਬੰਨ੍ਹ ਕੇ ਰੱਖਦੇ ਹਨ।
Now that we have learnt so much, let us now discuss a few questions and answers. My first question: do orthophenol and para-nitrophenol have hydrogen bonding in their molecules? Explain which of the two has higher boiling point. And the answer is both have hydrogen bonding. Orthonitrophenol has intramolecular hydrogen bonds, but due to larger distance between nitro and hydroxyl groups in para-nitrophenol, there is no such bonding. However, there is intermolecular hydrogen bonding in para-nitrophenol, and therefore it exists as associated molecule. In orthonitrophenol, no intermolecular hydrogen bonding is possible. Due to associated nature of para-nitrophenol, it is less volatile and has high boiling point. Hydrogen bonds are about 10 times stronger than dipole-dipole interactions and dispersion forces. Compounds capable of forming hydrogen bonds have unusually high boiling points, since transferring molecules to the gas phase requires the breaking of hydrogen bonds. Let me ask you another question, which is based on the application of hydrogen bonding in day-to-day life. Why do woolen clothes, cotton clothes require frequent ironing to keep them in shape? Does hydrogen bonding play any role in this? And now the answer is, let us have a look at an animation to understand it better.
Hydrogen bonding and ironing. Woolen trousers, skirts ਅਤੇ ਫਾਈਬਰ ਨੂੰ ਸ਼ੇਪ ਵਿੱਚ ਰੱਖਣ ਲਈ ਅਕਸਰ ਸਟੀਮ ਪ੍ਰੈਸ ਦੀ ਜ਼ਰੂਰਤ ਪੈਂਦੀ ਹੈ। ਵੂਲ ਪ੍ਰੋਸੈਸਡ ਸ਼ੀਪ ਫਾਈਬਰ ਹੁੰਦਾ ਹੈ। ਇਹ ਪ੍ਰੋਟੀਨਸ ਦਾ ਬਣਿਆ ਹੁੰਦਾ ਹੈ। ਵੂਲ ਥ੍ਰੈਡਸ ਵਿੱਚ ਲੌਂਗ ਪੋਲੀਪੈਪਟਾਈਡ ਮੋਲੀਕਿਊਲਸ ਐਕਸਟੈਂਸਿਵ ਹਾਈਡਰੋਜਨ ਬੌਂਡਿੰਗ ਰਾਹੀਂ ਜੁੜੇ ਰਹਿੰਦੇ ਹਨ, ਜਿਸ ਨਾਲ ਫੈਬਰਿਕ ਵਿੱਚ ਮਕੈਨੀਕਲ ਸਟਿਫਨੈਸ ਆਉਂਦੀ ਹੈ। ਇਸ ਕਰਕੇ ਅਸੀਂ ਇਹਨਾਂ ਵਿੱਚੋਂ ਸਿਰਫ ਹੱਥਾਂ ਦੇ ਰਾਹੀਂ ਵੱਟ ਨਹੀਂ ਕੱਢ ਸਕਦੇ। ਹਾਈਡਰੋਜਨ ਬੌਂਡਸ ਪਾਣੀ ਅਤੇ ਗਰਮੀ ਨਾਲ ਟੁੱਟਦੇ ਹਨ। ਸਟੀਮ ਪ੍ਰੈਸ ਵਿੱਚ ਇਹ ਦੋਨੋਂ ਫੈਕਟਰਸ ਹੁੰਦੇ ਹਨ। ਹਾਈਡਰੋਜਨ ਬੌਂਡਸ ਟੁੱਟਦੇ ਹਨ ਅਤੇ ਪ੍ਰੈਸ਼ਰ ਫੈਬਰਿਕ ਨੂੰ ਸਿੱਧਾ ਕਰ ਦਿੰਦਾ ਹੈ।
Today we learnt a lot about hydrogen bonding. We discussed about strength of hydrogen bonding and explained the causes of formation of the bond. We also discussed the differences between hydrogen and covalent bond. ਬੱਚਿਓ, ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦਾ ਇਹ ਪਾਠ ਕਾਫੀ ਦਿਲਚਸਪ ਲੱਗਿਆ ਹੋਵੇਗਾ। ਧਿਆਨ ਦੇਣ ਲਈ ਸ਼ੁਕਰੀਆ। ਅਗਲੀ ਵਾਰ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ। ਉਦੋਂ ਤੱਕ ਲਈ ਇਜਾਜ਼ਤ ਦਿਓ।